all right, is they set up the boxes in increasing order from top to bottom. So what that means is they put the boxes in order with the way you see in the diagrams there. They start at the bottom and they'll put 1s, then they'll go up and put 2s, then they'll put boxes like this, and that's your 2p. So I'm just using the example from the book right there. This is on page 41. So the way they have the boxes aligned is with the lowest energy level first, and then it's increasing energy level as you move up. Now, a couple notes with filling the orbitals. All right, first off, each box equals a pair of electrons. Each arrow equals an electron. Now, there is an order that you have to fill it. So, the direction of the arrow is the direction of the spin. So it just represents a spin. So an up arrow represents a spin clockwise. The down arrow is counterclockwise. So the way they end up drawing it is they'll have two arrows in a box going opposite directions. So that means the spin of them is opposite of each other, which helps minimize the repulsion. Now, when you're filling the boxes, the first thing you have to remember is there's multiple boxes in the energy level. So like once you get to 2p and above, you have to fill each box first if you have enough electrons before you go back and pair them up. So just a side note, each box must have one electron before pairing. Okay, that's because just in the sense of where the electrons exist in the atom, if there's a region of space that they don't have to occupy together, they're going to choose to do that because they have the same charge. So they want to try and stay separate from each other as much as possible to minimize the repulsion. Now obviously, as it starts to fill, they have to get paired with each other. But by adding one in each box first, what you're actually doing is you're minimizing the repulsion because now there's nowhere else to go but back and spinning in the opposite direction. All right? So let's just do one of the examples in the book. We will do, let's see, they do carbon, nitrogen. Let's do fluorine. Okay? So we have fluorine. So my configuration for fluorine is going to be 1s2, 2s2, 2p5. So I'm just going to draw my boxes down here. I got the 1s box, the 2s box, and the 2p box, which will have 3, because remember, each box can have a pair. The S subshells can only have a maximum of 2 electrons. The P can have a maximum of 6. So if each box holds a pair, 2, 4, 6. All right? So then all I do is I go through and I start to fill in my subshells. So I start with the first one in my configuration. So I'm just going to take a look here at 1s2. Okay, I'm just going to take a look here at 1s2. So I start by first putting one arrow in the box, and I always like to start in the up direction. Doesn't matter, really doesn't matter, because as long as when you make pairs you have 2 arrows pointing opposite, you're fine. So I have 2 that fill there, so I completely fill that box. I now move on to the 2s. Again, I have 2, so I just fill that box with the arrows pointing in the opposite direction. Yes?
Like last year, Miss Hernandez showed us that like you do like half in there, like
Yeah, you like that and like that. That's fine too. Okay, so now I get to 2p. So I've done 2s, I've done 1s, I've done 2s. Now I'm on to 2p. Remember, I have to fill each box first with one electron before I can go back and start to pair them. So, here's one electron, 2 electrons, 3 electrons. So now every box in this orbital has been filled with at least 1 electron. So now I have 3, that still leaves me with 2 left over. So now I can go ahead and go back to the beginning and start to pair them up. So I go in opposite spin. So there's 1, there's 2, so that gives me 5. So I'll only actually end up with 1 box without a pair of electrons. Does that make sense? Okay? So what we're going to do now